Here we are for day 23. We have a few more days to go. Today's, tomorrow's, and 25th. And then that should be it with 50 stars to get us to our vacation according to the lore. Yesterday's was okay. I don't think there's anything really particularly tricky about this one. The big thing was just, proper usage of certain things. I don't know why I was thinking an immutable list was the thing to check. But I replaced that with the queue, which is, the proper thing to do if you're always going to be removing and adding in the same position. Immutable list is a little more helpful if you want to insert at, say, like the very middle of a list, and you want to do a ton of those inserts at the same time. Those immutable collections can be really helpful in those scenarios. And I guess the other thing was learning that you can't really use some of the more complex objects as the hash objects. So you can use a tuple as a hashed value in a hash set, or the key in a dictionary. Those seem to hash just fine. But if you're using something like an integer array, those don't really do it. You can still add them to a hash set, and it seems like you'll be able to even add the same array. But if you wanted to check if, that hash set contains that integer array, you're going to have to actually parse through it, which kind of defeats the whole purpose of having a hash set. So that area of the solution for 22 probably could have been improved, figuring out how to add an integer array into a hash set so that you had a sort of, linear running time of looking up entries. All right, let's see what we got for day 23. Small crab challenge you to a new game. Crab is going to mix up some cups, and you'll have to predict where they'll end up. The cups will be arranged in a circle and labeled clockwise. Your puzzle input. For example, for your labeling 3, 2, 4, 1, 5, there would be 5 cups in the circle going clockwise 3, 2, 4, 1, 5. Before the crab starts, it'll be designated the first cup in your list is the current cup. The crab is then going to do 100 moves. Each move, the crab does the following actions. The crab picks up the 3 cups that are immediately clockwise to the current cup. They are removed from the circle. The cup spacing is adjusted as necessary to maintain the circle. The crab selects a destination cup. The cup with the label to the current cups, label -1. If this would select one of the cups that was just picked up, the crab will be subtracting 1 until it finds the cup that wasn't just picked up. The crab selects a destination cup, the cup with the label equal to the current cup's label -1. Okay. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. So we'll need to keep track of the last cup picked up. If at any point in this process the value goes below the lowest value on any cup's label, it wraps around to the highest value on the cup's label instead. Okay. The crab places the cups it was just picked up. The crab places the cups it just picked up so that they are immediately clockwise to the destination cup. Immediately clockwise to the destination cup, okay. They keep the same order as when they were picked up. Okay. The crab selects a new current cup, the cup which is immediately clockwise of the current cup. Okay. Is the puzzle input always going to start with 3? Is that what it's telling me? No, this one isn't a 3. Alright, so this one, I think I am actually going to use an immutable list because we're doing a lot of removes and inserts. Or maybe not. I mean, we only have... we'll create an immutable list anyway. So let's see. Mutable lists, integer cups. And down here, we'll say read all text, do character array, select parse d. All right. Let's check that real quick. Can I? Oh. Do immutable list. All right, so we get a list of cups, 3, 2, 4, 1, 5. Looking good. All right. Each move, the crab does the following action. The crab picks up the 3 cups that are immediately clockwise of the current cup. Oh, I see. It picks up 3 cups. I see. The crab selects the destination cup, the cup with the label equal to the current cup's label -1. Destination is 2? Oh, I see. Crab places the cups it just picked up so that they are immediately clockwise to the destination cup. So it takes 8, 9, and 1 and puts them after 2. Okay. Crab selects a new current cup, the cup which is immediately clockwise of the next one, which is 2. In the above example, the cup values are the labels as they appear moving clockwise. After the crab is done, what order will the cups be in? Starting after the cup labeled 1. Collect the other cup's labels clockwise into a single string with no extra characters. Each number except 1 should appear exactly once. So that's 9265. Okay. 100 moves. The order after cup 1 would be this. Okay, so we have to do this 100 times. So let's get the length, the number of cups that we have. We'll go 100 steps. And we'll let's see. We'll start at cup index 0. And what do we also need to keep track of? The crab selects a destination cup, the cup with the label equal to the current cup's label minus 1. Oh, if this would select one of the cups I was just picked up, the crab will keep subtracting 1 until it finds a cup. Let's see. So I guess we don't need to track the index. The index is always going to be whatever I is modulus the cup length. So we first need to take the next 3 cups. Next cups equals cups dot we'll skip cup index equals I modulus coupling. We will skip cup index plus 1. Ooh, how do we take... Well, I guess we could just do this. What am I doing? It's going to be cups I plus 1 modulus coupling is going to be the first one we need to take. I don't know. What'd you say? Cup 1, cup 2, cup 3. We'll remove these. And then what are we going to do? We're going to get the destination. Destination equals if I is greater than I equals 0, then the destination is going to be, no wait. It's cups I modulus coupling -1. If destination equals cup 1 or 2 or 3, let's see. If at any point the process value goes below the lowest value on any cup's label, this wraps around to the highest value. So let's get the minimum cup. Get the min and max. Destination is less than greater than or equal to min cup. What am I doing? Let's see. And then we need to place cup 1, 2, and 3 after wherever min cup is at, or the destination cup. So cups index of is we'll say cups insert zero-base index at which to insert the object. That'll be new index. And we'll insert cups 3, and then 2, and then 1. Okay. Let's see. Outside the range of values, I is 1, cup length 5. Oh, the cups is only 2? What step is this? Step 2. What were we supposed to do here? I guess cup length -3. Inside the range, new index is -1. Guess we should do this up here. All right. What does our cups look like? 32415. Oh, yeah, let's try this input instead. What do we get? The order after the 1 cup. 6738. No, that's not what we get. Let's take this down to 10 moves. And let's print out some things. So we'll first start with cups. Right, lined cups. Then we'll print out I guess just call this take. Cup 1, cup 2, cup 3, and lastly, we'll print the destination. All right, what does this look like? So we have 389, we take 891, destination is 2. Now we have 3891. Okay, so we need to insert new index equals index of des plus 1 modulus cup length -3. I think that should be right. Okay, so right, 32891. This one says take 3. All right, 891. 325. That's not what we want. Move 3 seems to be wrong. So 891. We should be 3891. 32. What? Yes, this should have taken 891 and put it in after 5. But instead we have it here at the beginning. Why? Probably this guy right here. So we got to this stage where we got here where we're on cup 2 in 891. It should have gone into here. Let's see, step 0, step 1. So we've taken 891. The destination says it's 1. If destination equals cup 1 or cup 2 or cup 1, then subtract. If destination is less than min cup, then destination equals max cup. And then what are we supposed to do? Wraps around to the highest value on any cup's label instead. Oh, no wait. What? Eight, 9, 1, so the next highest would be 7, right? Oh, it does say destination 7, doesn't it? So I shouldn't be saying... shouldn't be using that min and max. I should be specifying min here after I remove the 3 cups. Min cup equals cups dot min, and max cup equals cups dot max. Okay. So how does that look? 891, 325, still incorrect. Alright, here's step 1, here's step 2. Says the destination is 1. We grab the min and max, which is 2 and 7. If destination of 1 is less than 2, then destination equals max cup, which is 7. All right, that looks good. The index of destination. Ooh, index 0. What? Index of 7, which should be 5. Plus 1 is 6. Modulus of what, 6? That's going to be 0. Ooh, but that's not how this treats it. This treats it as if... Oh, that's weird. Oh, how do we handle that? So I guess we need to turn this to an add. We'll do new index. And we'll say if new index equals cup length minus 3, then we'll just add the 3. else we'll insert them. We'll do step 1, 2, 3. Sends this to add. Get rid of this. All right, let's try that. All right, 891, destination 7, 467. That looks good. Or does it? Let's see, 891, then 32891, and then 325467891. This one says destination 3. Yeah, that's right. Ooh, but the next one is wrong. This move 4. What happened here? 7246. So we're at 325. Destination 3. What? We're picking up 467. Right, we take it out. And we add it after 3. Yeah. Which is 467 down here. But you're... How did 3 make its way over here? Why is 7 over here? What the heck? Alright, if we take away 467, it would be 5891. Oh, and 3 would come over here. Why would 3 come over? Hmm. Oh, I guess we do need to track the current cup. So current cup Oh, maybe we'll do this. Just say cup stat first. Index of current cup. So this is +1. +2. +3. And then after we take 3, we will say current cup is equal to cups at whatever the next cup is. Okay. Destination is why were we doing I here? We can just do this. Cup index of 6. Oh. I guess once we update that, we'll need to update the current cup again, or the cup index. Five 74183 926. This is move 10. Why are we saying this is the final one? Do we need to do one more? Let's get the code for producing the final. It's going to be the length of the cups. So cups index of 1 I is less than length, cups.count plus and the result plus equals, let's see, cups I modulus cups.length cups.count dot toString. And that is 19261. $926. Why only 3? Oh. Nine two. I can barely see that. The result is 92658374. Okay. All right, so that looks good. Let's try with 100 to make sure that works too. We get 6738. Yeah, looks good. All right, so let's try with our puzzle input. Let's return the result. And I'll let it print out. It seems to be fine enough. All right, we got that part done. Part 2, due to what you can only assume is a mistranslation, not exactly fluent in crab, you are quite surprised when the crab starts arranging many cups in a circle on your raft, 1 million in total. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered in an increasing fashion, starting from the number after the highest number in your list, producing 1 until 1 million is reached. For example, if you're labeling 54321, the cups that would be numbered, and then start counting up from 6 until 1 million is reached. Crab's going to hide your stars under the 2 cups that will end up immediately clockwise of cup 1. You can have them if you predict what the labels on those cups will be when the crab is finished. In the above example, this would be 934001. What? Oh, those are the cup numbers. I was like, why are these cup numbers so big? Now, are we going to be able to do this with 10 million cups? How strong is our immutable list? Oh, 10 million moves. Oh. Well, let's just get it over. See what it looks like at least. So let's get our code down here. And then in this one, 10 million. 10, 1, 2, 3, 1, 2, 3, 10 million. So we need to add 1 million in total. We're gonna go until 1 million minus let's get rid of some of this debug stuff. And down here, cup 1 equals cups at cups index of 1 minus 1. Cup 2 is the same except plus 1. Cup 1 times cup 2. About cup A and cup B. Alright, so it's running. Let's pause it real quick, see where we're at. We're at step, we're only at step 175. So that's significantly less than step 10 million. What can we do? I mean, we're going to get to the point where we're increasing up, right? So let's make this a length of 50. Let's go, I don't know, 500 steps. We'll print out the cups on each step. So what does that look like? We start out, we get to the last cup. Oh, this should be 10, not 9. Let's add 1 here. All right, let's look at this. Can we pad right inside of a string join? I'm getting distracted. What was this? 1 million? 2, 3, 2, 3. This was 10 million, 10, 1, 2, 3, 1, 2, 3. Okay, we're still slow. I wouldn't think it would be that slow to move through just this many, move through a single iteration. Maybe I should use a dictionary. I mean, we do have this index of, which is basically searching through our list. But if we used a dictionary, I'd have to update every single index. Let's see if I can get rid of this index search. So we change this back to I. I guess we can keep track of an offset. What was the issue before? It was where when we removed 467, When do we need to update the offset? I guess we can also probably improve this by only grabbing the max if the max is not in our list of cups. Well, we have to update. What? Declared it right here. Oh, because it's complaining down here. And we'll say if Min cup is in I guess I'll do this. I'll do the same thing for max. Let's see, max, min, max. No, we don't want to do that. See, we're not behaving correctly. Oh, I guess we need a different test input. Here we go. Let's verify we're working correctly. What? 38912. Oh. Well, that doesn't help if this guy over here is messing with the cups. Okay. Nope, something went wrong here. E91, E91, 467, and then 258. So that was our problem previously. What did we have to do? 325, 467 is going to go in front of 3. Hmm. This is where we add our offset. So our offset needs to be 913, 913 and 2. This is where it messes up. So it's saying I plus 3, position 6. No, why is it off by one? Should the offset only be 2? No, it was right on the other ones. I guess 913. It's off by 1 because hmm, can't binary search on a non-sorted array. Hmm. You can't easily find the offset like this since the cups that are taken I guess I can take the cup index for each of these. Sure if that even makes sense. No, it doesn't. Hmm. Guess I could get the destination before I remove all this stuff. I don't really need to worry about the offset, would I? No, I do need to worry about the offset. Nine one three seven. Okay. It took way longer to figure out than it should have. Let's see, 913. Oh, why are you 791? Three, four, six, seven, nine, five. 913 and 7. Why is 791 here? I'm off by 1. And that's this guy's fault, isn't it? Hmm. Lost. This is wrong. Oh, it was right. I was looking at the wrong thing. Okay. Alright, so let's give this a couple more. We don't want to print. We're slightly faster, but nowhere near where we need to be. Yeah, let's pause a bunch of times and see where we're the slowest. Yep, it's that index of. Yeah, what would be... Now, what's a good way to search for index of? Or, yeah, the destination. Is the destination always going to be behind us? No. Ooh. It looks like at this point, the destination is always in front of us. So let's see, destination is 27097. One 105, 109, 113, 117, 121, 125. So it looks like it's always 4 off once we get high enough. And then cup 1, 2, and 3 looks to be 27127, 27128, 27129. Destination is 27125. Everything's increasing by 4. So I guess once we get to a certain point, we can just assume that we're in a repeating mode. So let's see. We'll save the last cups and the last destination. And once we get here, we'll say last cup 1 plus 4 equals cup 1 Are you ever gonna break? Oh, help if I set the last bet, I guess. All right, so it broke on I4, really? Why is max cup only 500,000? Oh, because we're counting. Yeah, it's stopping a lot sooner than I assumed. Hmm. Step 4, step 6, step 8, step 10. Yeah, this isn't true for every step. But it looks like it's like every other step. Oh, we got a different pattern here. So it goes 295 to 299. So that's the 4 jump. And then from 299 to 303, that's another 4 jump. 4. This one was a jump of... Oh, that's because it's of this break that I'm doing. Let's break at 50 just to be safe. And then down here, oh, we need... CA1, 89 and 3, 93 and 3, 97. So let's see. So I guess we just need to take these. And then CA is going to be that doesn't make sense. Oh, the 2 cups that'll end up immediately clockwise of cup 1. Not before and after, but this one and this one. 1 and 2. Hmm. Oh, it's impossible to have these numbers. Hmm. Yeah, these practice quests, or the practice answers we have down here are interesting. They're not really what I'm seeing running through this. I mean, after a bit, I'm getting sort of an exact everything's being increased by 4. Telling me that 1 is at the very end of our list? Ah, because at one point we must have gotten the max value and threw it over there. Hmm. Where's new index? Wait, why is the new index always the same? Hmm. Alright, it starts at 1,000,000. No, it starts at 0. 97 to 1. That significantly speeds things up. But how do I know that's right? Let's see, for this one, new index is 2, and then 6. Two, 6, 1, 3. Destination follows a sort of pattern. Can I figure out the destination somehow? Nine. Doesn't really follow a pattern for this one. Yeah, I'm not sure about this one. I'm assuming that there's some sort of pattern that occurs, and then you figure out that pattern, and then you can figure out, n equals whatever, and just calculate the answer at 10 million. I mean, at one point we go through and we're just basically moving the same 3 cups to the same destination. The destination always seems to be at like the very end. It's going to take a long time to go through. I mean, the performance improvements that I added have made this a bit simpler. But I'm not seeing why. Or, I mean, I know why it's faster, but I'm not seeing what to do past this point. I'm a little too tired to think properly here. I mean, I have a list with 1,000,000 numbers. So our max is 1,000,000. Would it be 1,000,000? Why is our max 1,000,000? Wouldn't it be no, 1,000,000's right. Our list of test numbers, what was our input numbers? 1, 2, 3, 4. So we do have every number from 1 to 1,000,000. The only difference being our first set of numbers, it's a bit jumbled. We are we're still getting to the point where we're taking 3 numbers that are subsequent to each other and adding them to whatever this destination is. Does that mean we don't really need to have this additional 1,000,000 numbers? I mean, I guess we do. Hmm. Well, we got rid of the index of piece, so we're not really searching through the list. I mean, our only bottleneck here is just simply the fact that we're moving stuff around, I/O bottleneck. So really, I mean, the solution can't be us moving these numbers around in this list. It needs to be something else. It needs to be us determining what this pattern is and then figuring out how to calculate that pattern. Yeah, once we find the cup that has a label of 1, or a cup that is close to 1, I guess, we're going to end up changing the new index to the end, which is going to be 1,000,000, or 1 less than 1,000,000. Yeah, so I guess maybe the key is hitting when we get to the point where we change the destination to the max cup value. So we go from 1 to the end, and then from there we start adding we start moving all of the cups to the end, like reversing them. Yeah, because the destination is 1 less than the current. So that occurs here and here. Where we set the destination to the max cup value. 891 3 8, 9, 11, 12, 13. Guess we're like adding every other 3. And once we get to 1,000, hmm. Maybe I should just run this and go to bed. Yeah, I can't do this and skip the... And it's back to being slow again because of this index lookup. Hmm. Yeah, I might be stumped on this one. Hmm. It's like some kind of weird sorting algorithm. Mm. think even if we sped this up, it still wouldn't be a very good solution. Like currently, the biggest slowdown is finding the index of whatever the destination cup label is. This guy right here, which is a linear time search. Everything else in here is constant time or close to it. Well, it is constant time. Yeah, but even if everything was constant time in this whole thing, it'd still be pretty slow doing it, 10 million iterations. Mm. Yeah. I think I'm gonna call it quits. I'm gonna have to refigure out a completely different solution for this. I'm sure it's not the, iterate through 10 million times. I'm sure there's got to be some sort of, constant solution. I was thinking that maybe the structure of your input kind of might be a hint at what the sorting behavior is going to look like. Sort of get to the value 1 and then start adding pretty much every value to the end of the list. And then once you get back down to something, yeah, I don't know. Yeah, I think that's it for this one.